We are a little less than 2 minutes from the beginning of the program. 2 minutes to the beginning of the program.
Well, hello and welcome to Living and Working in Extreme Environments. My name is Ryan Schaefer, and I am joining you live from the Johnson Space Center in Houston, Texas. I want to welcome with me Dunbar Middle School, who is from Lubbock, Texas. We also have Key Peninsula School joining us from Lake Bay, Washington. We also have Cole Middle School, who was unfortunately not able to join us interactively, but I believe they are watching us via the web, and they are from Lancaster, California. So welcome one and all. We also have a number of people watching us on the web. Now, you've all heard of outer space, right? Well, instead of taking you to outer space, we will be taking you to inner space. That's right, 60 feet below the ocean surface is a habitat called Aquarius. And in about 15 minutes, we will actually join a real live aquanaut who's living in Aquarius as we speak. But first, I thought it'd be good for you to watch an interview I did with some engineers who are directly involved with NASA's Extreme Environment Mission Operations, better known as NEMO. I'd like to welcome two special guests to our studios today. Could you two introduce yourselves and give the students out there a better idea of how you'll be involved with NEMO 14?
Sure. Absolutely. Hi guys, I'm Heather Paul. I'm a mechanical engineer that works here at the NASA Johnson Space Center. I've been out here for about 14 years, and this year I have the fantastic opportunity to work with NASA's Extreme Environments Mission Operations Project, that is the NEMO activities.
My name is Amanda Knight, and I'm also a mechanical engineer. I've been out here at NASA Johnson Space Center for about 6 years now, and this too is my first opportunity, and I'm very, very excited about it.
Great. Well, thank you for joining us today. I guess to begin, Heather, could you give us a brief explanation of the NEMO program?
Absolutely. Well, it's pretty cool, Ryan, because we get to go to Key Largo, Florida for a couple of weeks in May, where we're going to be working with a crew of 6 in the underwater Aquarius Habitat. So that crew of 6 is comprised of a NASA astronaut, a Canadian Space Agency astronaut, 2 scientists/engineers, and then 2 habitat technicians. And they're going to be going out to the Aquarius Habitat, which is about 60 feet underwater, for 2 weeks to do an underwater Aquarius mission. And that's really NEMO 14. Lots of great activities, doing spacewalks, doing science objectives, engineering tasks, and overall fantastic opportunity.
Well, thank you, Heather.
Sure.
I guess it might help the students, though, if we actually show them how the Aquarius Habitat works. And I think we actually have a demonstration that we want to show them in order to explain some of the science involved with living underwater. So what are we seeing here?
Okay, so right now what we have is basically a tank of water, which we're going to pretend is our ocean right now, and the bottom would be about 60, 62 feet down.
Okay.
And here we've got our glasses, which we'd like to pretend is our Aquarius Habitat, right?
That's right.
So here we go. We're submerging the Aquarius down into the water, down to about 60 feet.
And there's an air bubble in
That's
there.
right. There's the air bubble. What would happen, you think, if we let go of that cup right now? There's so much pressure inside of it, it would just shoot up like a rocket. So one of the things that we are very mindful of when we have this Aquarius down that far underwater is that we want to make sure that the internal pressure where the crew is living inside the habitat is the equal as the water outside of it.
And even if we add an entrance,
Okay.
a hole
Right.
in this cup.
We've got to get in and out, right?
Right.
Okay.
That's true. So
now we have what we would consider our airlock so that the Aquanauts can actually go from inside the habitat outside to do their EVAs. And it's still very much the same thing. They're able to maintain the pressure inside and still be able to get outside to do their work as long as the pressure is equalized both internally and externally.
I see. So lots of science involved with living under the ocean.
Absolutely.
Definitely.
And now I think it would be even better if we actually show the students what the real Aquarius looks like. So let's go ahead and take a private tour of Aquarius.
All right.
Hello, my name is Dewey Smith, and welcome to Aquarius. I'm one of 2 habitat technicians. My job down here is to make sure that the aquanauts are safe, healthy, and being productive down here, and we'll have a successful mission. We're going to start the tour here, as you see, in the bunk room. These are where the 6 aquanauts sleep. It's pretty close and cozy, but it does the job. We don't spend much time in here, so there's a lot of space. This is where we keep all of our clothes and goodies and books for the cruise here. If you look forward here, right underneath the viewport and right underneath the grouper, we do have a workstation here. It's a fold-down station with a laptop with internet capabilities, and that's for anyone to use. And we'll go ahead and come on out here into the main lock, and over here to the right here, our starboard side, we're actually looking towards the bow, or through the bow, to the bow of the habitat. And on the starboard side, starting as a camera, which the watch desk has a constant eye on us 24/7 during a mission. We do have another workstation here. This is for me and the other habitat technician, Buckley. And this is where we have a live chat to the watch desk. So if anything happens, we have a live chat to them, as well as a barrage of phones. We have digital, landline, cell phone. And as we carry on through here, we have a depth gauge here, which shows us that we are at 47 feet of salt water. We have a bunch of monkeys here also. Some of the aquanauts. We got aquanauts coming back from a dive. They're eating and getting their meals ready, getting warmed up after the dive. Underneath that depth gauge, we have our sensors that show the oxygen, temperature, humidity, CO2, and CO readings and alarms there. Further back, we have our air distribution. This is where we get our atmospheric makeup. We have a 30 cubic foot bleed going on right now, and followed by our electrical panel, which has a bunch of buttons and switches there. That's how we get lights, camera, and action. We have another station here with another computer that also has Internet Connect. Back on the other side, to the port side, we'll see people eating, enjoying the loads of food that we have down here. We have a regular sink and utensils and a microwave like you would at any kitchen. And we'll carry on through into the entry lock. And we'll see another couple aquanauts here hiding out. You can't run from us, guys. We'll also have the same thing as I pointed out in the main lock. It's mimicked here, the electrical panel, air distribution panel. Right on. How'd the dive go, guys? All right. Good deal. No problem at all. All right, and this is a final space here. It's actually where it begins is in the wet porch. And the camera may fog up on us, but we'll try to keep it clear for you so you guys can see what's going on in here. This is where the power and air come through into this space right here. We have an air distribution panel, as we saw in the main lock and entry lock. This is how we distribute it inside. And if you can see through these, you can see the moon pool. We do have some gear drying. This is where all their gear is staged. This is where we stage out and do our dives and all the work. This is why we're here. The shower is a small space, but it gets the job done. Hopefully you can see that. And there's also another camera in here that is a direct link to the watch desk, and they can watch us from here too. Thank you for joining us. We'll go ahead and sign out. And thank you for listening and watching, and we will see you guys soon, hopefully out in the water. Good night.
Well, that's certainly a fascinating facility, Heather.
It's awesome.
But you know, when people think of NASA, they think of launching really big rockets, and they think of astronauts floating in the station.
Sure.
And that's really different than what we're seeing taking place at NEMO. So, Heather, can you give the students a better indication of some of the differences between living in outer space as opposed to under the ocean?
Absolutely. Yeah, you're right. I mean, when we think about NASA, we don't think about going underwater unless we're doing a simulation or a training at one of our training facilities. So what NEMO 14 allows us to do is it's an analog activity, or it's analogous to what we would experience living in outer space. And there's definite differences because obviously you're at high pressure underwater and you're at low pressure or in a vacuum environment in space. But there's more similarities, and that's why we do the NEMO 14 activities. So for instance, living inside of a habitat, that's just like living in the space station, except it's actually a much smaller volume. So the Aquarius Habitat is about the size of the Zvezda module that we have on the International Space Station. And we're looking at the psychological and scientific and medical aspects of having a crew of 6 living in a volume of that, a space of that volume, seeing how they interact, live, and work together. So that's one of the aspects of our NEMO activities. And then of course we have EVAs, or extravehicular activities. So just like we do EVAs or spacewalks outside of the space station to maintain the habitat, maintain the station, we do the same things with our Aquarius Habitat, where our crew will go outside every morning and afternoon to do a spacewalk. So they'll be checking on the habitat, but they'll also be doing specific scientific and engineering objectives, just like we would do on a real space mission.
And correct me if I'm wrong, but I think, Heather, can't you weigh the scuba suit in a certain way to model different planetary surfaces?
Absolutely, and that's a really critical part of what we're trying to do, because as we design our spacesuits, really what we're interested in looking at is how the crew moves, how they feel, is it easy or hard to move around, and to what extent do they have to compensate or change the way they would do a movement to successfully execute their activities while doing the spacewalk. And that's especially critical when you talk about going to the moon or on to Mars, a planetary surface where you're going to have gravity. So what we do with NEMO is we can weigh you out depending on what gravity level we're trying to simulate. So we can make you neutrally buoyant where you float in the water column, just like you would in microgravity, or we can attach weights to you and weigh you down to 1/6 gravity or 1/3 gravity to simulate lunar or Mars gravity environments. And that's exactly what we're doing on several of our EVAs this time.
I see, and it's a specialized kind of suit. I mean, it's not just a normal regular scuba suit. This is some pretty advanced materials that you're using.
Absolutely. I mean, it's not as advanced as the extravehicular mobility unit that we have in space, but it is a special gear that the Aquanauts will be wearing.
I see. Well, Amanda, there's some other similarities, I guess, between NEMO and the International Space Station.
Right.
I think isolation is one of them.
Definitely. Isolation is a big one. Not too many people realize, the different kinds of challenges that actually come about by having 6 people live in a very, very, very small environment. And that's something that happens not only on station, but is what we're also simulating and mimicking down here in the NEMO 14. So there is that isolation aspect, as Heather mentioned, trying to look at the psychological differences, impacts, so on and so forth. Also, one of the other similarities that we have is the mission control. So whereas the Aquanauts in NEMO, they're able to talk to each other, there's not necessarily someone that they can just reach out to and be like, oh, I need some help. Well, they can talk to mission control, which is, up on Key Largo, but it would simulate very much what we have here at Johnson Space Center when our astronauts are out in space living on the space station. There is that difference, and for 2 weeks, our Aquanauts are submersed underwater they are communicating just the same way that the astronauts would out in space.
I see. So lots of planning goes into Nemo.
Absolutely.
And I
A
think,
little bit, a little bit.
I think one of the things that is focused upon is robotics, really, right?
Definitely.
So Heather, can you talk a little about all of the robotics research that's being done at Nemo?
Sure, absolutely. And robotics is a pretty key element. When we're talking about human space exploration, it's not just humans. You need some robotic assistance so that it's really a great partnership between human and machine. And so when you're developing robotics, it's important to figure out how you communicate back and forth with your robotics and how you would perhaps control it. So for instance, using a remote operated vehicle or driving a rover out unmanned before we put humans inside to go off and explore the lunar traverse and terrain. That's a really key aspect. And in fact, we're definitely doing those kinds of things with NEMO during our spacewalk activities.
And these robotics could be a rover, like you mentioned.
Right.
So I think the acronym that we use is ROV, Remotely Operated Vehicle.
Sure.
What size do they come in? I mean, are they small or do they get bigger than that?
It really depends on what you're trying to do with the ROV. So we do have a mock-up of one of our lunar traverse rovers that you would actually sit in and drive, but then we do have a much smaller, it's about, this big, kind of a small little guy, that's our remote operated vehicle. And so it just really depends, Ryan, on what you're trying to do. We have robotic assistants that need to be very small so that they can move quickly. Say, for instance, if you wanted them to go out and scope the lunar terrain and look at different geological or rock structures. But then you might need something bigger if you need to, say, drill into the lunar surface or go take your habitat somewhere else on the lunar or Martian surface.
That's very good information. Thank you so much for joining us today, Heather and Amanda. And I hope you two accomplish many, many things during Nemo 14.
Thank you so
very
much.
All right. Goodbye.
Bye. Thank you.
Alrighty, students, I hope you enjoyed that interview as well as that private tour of Aquarius. Now is the time to speak with a real live Aquanaut who is living in Aquarius. I think we have an Aquanaut on the line, is that right?
Yes, indeed. I'm Steve Chappell here talking to you as one of the Aquanauts living on the Nemo 14 mission down in Aquarius, 60 feet below the ocean surface off Key Largo.
Well, good afternoon, Steve, and thank you for joining us. We have a lot of anxious students that are looking forward to asking you a lot of very, very cool questions. They just got done watching an interview I did with Heather Paul and Amanda Knight. They also got to see what the habitat looks like. But before we start asking questions, I thought it'd be good for you to explain a little bit more about the NEMO program and how you're involved with Nemo 14.
Certainly. The NEMO program stands for the NASA Extreme Environment Mission Operations Project. And we work hand in hand with NOAA, the National Oceanic and Atmospheric Association, who runs through working with University of North Carolina, Wilmington, the Aquarius Habitat here and the Aquarius Reef Base on shore. And the project has been going on for a number of years. This is the 14th NEMO mission that we've undertaken, and it is one of a few analogs, or what we call analogs, that are simulated environments that help us to understand how we can design and work and design systems and learn how to work in space. And it's good at that for a number of different reasons that I hope some of your questions will get at. And my particular involvement here is part of the NASA team of four, including two astronauts and myself and another Aquanaut who is. We're all working together as part of a total six-man team, with the other two being professional Aquanauts that run and keep this habitat working and functional for us to do our research in.
Very, very cool, Steve. And I think, you have to say that the Aquarius Habitat itself is really only the most visible part of the NEMO program. I think you mentioned something about all of the support people on shore. Maybe you could give the students a better idea of how this is all possible and what kind of backup you have making sure that you stay safe.
That's a very good point, and I think you're seeing a picture now of the Aquarius Reef Base headquarters based in Key Largo. There's a facility that has basically the ability to function as a mission control center that works with the Aquarius Habitat through a series of communication link-ups that are provided through our life support buoy that sits up on the surface above the habitat. And it's really quite an extensive system of ships and boats that can go back and forth between the reef base and the habitat to make sure that the life support buoy is working well, that we're fully supplied with the materials that we need to do our research, and when we're doing experiments down here that we can transport those types of things up to the surface for further analysis. You're seeing a picture now of our mobile mission control center that's based outside of Aquarius Reef Base. During these missions, a whole staff of folks there that are working to make all of this possible behind the scenes, actively working long hours, analyzing the data and planning what it is that we do down here in a way that will maximize research that we get out of this.
Very, very interesting, Steve. And I guess with that out of the way, we can go ahead and get started with student questions. So my first school is Dunbar Middle School. This is your opportunity to open up your mics and ask your first question to Steve.
Why was Aquarius built off the coast of Florida? Could it have been placed somewhere else? Look at me.
Yes, it could have been placed in other places, and in fact it was originally located in a different location, I believe down in the U.S. Virgin Islands, where it's been a few years. And then after some hurricanes went through there, it was brought back to the surface and refurbished, and eventually wound up here off the coast of Key Largo. Certainly habitats can be placed at deeper depths than other locations, but this depth is a good depth for reef research from a marine biology standpoint, and it also provides a good environment for other types of research, and it's about the right depth to allow us to not have to do complex decompression types of activities other than just standardly using normal air and things like that. Great question, though.
I see, and that was a great question, great answer, Steve. And just a friendly reminder, I think after you guys ask a question of Steve, be sure to mute your mic, because that can give Steve some feedback. So let's make sure we can mute our mics unless we are asking him a question. But let's go ahead and continue on. Actually, Steve, we had a middle school named Cole Middle School in Lancaster, California. At the last moment, it looked like that they were unfortunately not be able to join us today, but I think they are watching via the webcast. So I'm going to go ahead and ask their questions in their place. So there was a student there at Cole Middle School named Kevanisha Lyons, and what they wanted to know was, how did you ever manage to make or build a laboratory underwater, and how did you manage to stay in there for the amount of time that you have so far?
That's a great question, and the habitat was built onshore at a Shipworks facility, and it was eventually brought out here and brought down and anchored into the seafloor. It sits in about 60 feet of water. I can't speak to exactly how it was brought down, but it's down here now with a big platform that holds it to the seafloor. It weighs about 120 tons. The habitat weighs about 80 tons, and it holds and stabilizes the habitat even under extreme conditions. And it has air tanks and water tanks to help us keep our pressure, and it has that life support buoy you saw earlier that supplies us with other communications and other things.
So it sounds like, I'm sorry, Steve. Go ahead. Well, it certainly, the Aquarius Habitat is certainly an important research facility for many, many things, including marine life. And we'll talk about some of the other analog research that's happening as well. But there's also, human research, human body research that has been going on for the past several years during every NEMO mission. So Key Peninsula School, I think, had a question about that. And Key Peninsula, when you guys open up your mics, don't be afraid to introduce yourself to Steve. That way he can know who he's talking to.
Hi, I'm Donnie. How does being underwater for weeks affect the human body? How long does it take for being in the water for the whole waiting to get annoying?
Hi, Don. Great question. Being down here, it does affect the human body. It's part of the research that we're undertaking, and it is similar to the same types of effects that might occur and have been proven to occur on space shuttle missions and ISS missions, where we'll have changes to our blood that is to do with the different pressures and the environment that we're on. Our immune system changes, and they think that that's mainly due to some of the, just living in a confined environment with extra stresses, psychological stress and other things. And as we continue to do these missions, we'll learn more about exactly how those effects take place, and hopefully develop countermeasures so that we can use those to move out into the solar system when we go to more longer duration missions. In terms of weight, it's actually, in general, when we're down here, unless we put weight on us, when we're outside, we're basically neutrally buoyant. It's kind of like being in space. But we can add weight to ourselves to be able to walk on the seafloor and simulate walking on an asteroid or moons or Mars, for instance.
I see. So it certainly sounds like that the research that you're doing there at NEMO 14 will actually benefit some of the students that will be using it in the future. So very, very interesting. Now I think we'll go ahead and continue on with the questions, because I want to make sure we have time to answer most of them. So Dunbar Middle School, I think you have a good question for Steve.
My name's Max. What difficulties do you face living and working underwater?
Hi, Max. Some of the difficulties we have are not dissimilar to what you have, say, in space, where you're in an environment where you know that once you've been down here for a while, we can't go directly to the surface, for instance, without having medical problems. So we know that we're in this space, and the kinds of medical problems that may come up are kind of what we're studying, and while we're down here, we provide things such as saliva samples. We take different psychological tests. We provide blood samples and other things so that the scientists and researchers can analyze them, and we do those regularly on a day-by-day basis so that they can see the changes that are developing in our bodies over the days that we're down here. And then once we get to the surface, they continue to take that data and see how long it takes for us to recover. In terms of just general difficulties, you get used to it, but it is a fairly tight space for 6 people to live in. But you wind up getting to know each other really well, and it's actually quite easy once you've done it. You adapt quite well to it.
Very, very interesting, Steve. And speaking of difficulties, I think there was a student named Kenneth Walker at Cole Middle School who maybe wanted to ask you about some of the long-term effects of living underwater for so long. Hopefully there's not too many long-term effects, but there's probably some short-term effects that you'll experience once you go topside.
Indeed, there's some short-term effects that you do recover from, and some of those are to do with breathing the higher pressure air. It's basically, it makes it easier for our bodies to get oxygen, so our bodies start to realize they may not need something, as many red blood cells, for instance, to get the oxygen from the environment that we're in, so it gets rid of them. And when we go back to the surface into the normal air, the body has to reproduce those eventually, and it does. In terms of long-term effects, That's one of the things that's being studied here. We know that, again, living in the higher pressure air environment, it causes more oxidation. You may have heard of vitamins and other things called antioxidants that we take, and they help us to cut down on oxidation just in everyday life. But we have a higher incidence of that down here, and they're still studying the long-term effects, along with the same types of effects in space travel, in terms of whether there are effects that can be overcome.
Well, there you go. Just another example of the analog research occurring at NEMO 14. Now, Key Peninsula School, I'm going to have you guys come on again because I think you have a really good question, and I think we're going to be able to illustrate this really well.
Hi, I'm Antonia. How is controlling a rover different from on the moon?
That's a great question. In general, if a rover, for instance, we were trying to operate one from here on Earth on the moon, there would be a couple second delay in terms of if we were to issue a command for it to turn left or right or stop, then it would take a couple seconds for that to react. We can actually simulate that very well here on Earth, say from the Mission Control Center on shore or from in here. It's pretty easy to implement a delay in terms of to simulate that distance that we don't have, say, operating a rover on another planet. So it's a great training ground for helping to understand how we can develop systems that will help us drive those rovers and be effective at doing the science that we need to do when we do go to another place in the solar system.
And here, Tom, we were seeing an example of a smaller rover, but there is a larger rover that NEMO 14 has been researching, right?
Yeah, absolutely. There is a mock-up of a large rover that we have on this that's able to drive around on the surface of either a moon or planet. And the idea is that two astronauts could live in the rover and have their spacesuits basically attached to the outside of it. This is a mock-up that you're seeing here. It's being lowered off of a simulated lander to a surface. And the idea that once it's lowered off of a cargo lander on the surface of another planet or moon, it could be the astronauts would get inside and they'd have spacesuits that they could go out and do extravehicular activities or EVAs when they needed to, but much of their time would be spent in the rover, traversing and being able to look at the surroundings and analyze the surroundings, and then when they're done with their mission, they could go back to a lander that has what's called an ascent module on it that they would then go back into and return to Earth.
I just think it's incredible how we're able to learn about how we're going to land on the moon in the future, perhaps by going 60 feet under the water. I think that's just incredible. But let's continue on. I think there's a good question from Dunbar Middle School.
How was the crew chosen?
Well, I can speak to the NASA side. As I mentioned, there are two professional aquanauts that live here, and there's a number of other aquanauts that are part of the Aquarius reef-based staff, and they rotate in to take part in the different missions, so that they all get a chance to take part and learn how to take care of the habitat and be successful at research down here. And generally, there's the astronaut office selects the astronauts that are going to take part down here in terms of they look at it as a training opportunity for long duration space travel and for either on the shuttle before it's retired, or looking at commanding an ISS mission, for instance. In fact, Chris Hadfield and Tom Marshburn are the two astronauts that are living down here, and they're going to be flying on an ISS mission in late 2012 into 2013. So they're getting some great training here for that eventual mission. And in terms of myself and Andrew Abercrombie, we applied once the announcement was made, and we were selected through an interview process based upon our experience and backgrounds and what NASA thought that we could bring to the team. So I encourage you all to pursue science and education, science and math backgrounds, and find something that you really enjoy, and eventually you may wind up finding yourself and having the opportunity to take part in things like this.
There you go. I couldn't agree more, Steve. Now, there was one more question, I think, from Cole Middle School, and I think this is getting back to some of the spacewalking research that you've been doing lately. I think David Olson was curious about specifically Mars. Any research that you've done specifically having to do with Mars at all?
Yeah, many of the experiments that we're doing outside are related to wearing different types of backpacks that simulate, simulate a portable life support system being on our backs that what we would use with a spacesuit if we went to Mars. And we can put different weights on that backpack and in our suits in ways that simulate what's called different centers of gravity, such as if you're wearing a backpack and there's a lot of weight up high versus a lot of weight being down low, that will feel different, and it may affect the way that you do different activities. So we're going out with a number of different configurations of those weights, so that and performing activities such as working around rovers and airlocks and shoveling, collecting rock samples, going up and down ramps and things of that nature, and comparing how we feel and how we can perform under those different conditions with all those tasks, and hopefully with the idea to optimize the next spacesuit that we design to go to Mars, so that we can do what we need to do more effectively when we get the chance to go.
Very, very interesting, Steve, and I think to give the students a better perspective, I think the gravity on Mars is something like 2/5 of the gravity that we have here on Earth. So I guess what your job is to try to match that as precisely as possible, so you can learn more how an astronaut might perform and do his job while on Mars. Now, we're going to go to Key Peninsula School again, because I think there is a young lady there that has a question about electrical power.
Before we do that, I think we have a visitor. Outside. One of our crewmates here, Nate Bender, is outside and saying hi to us all. And everybody wave to Nate. And Nate's also, just real quick, his sister, Miss Ann Field, may be listening in from Mountain Home, Idaho, and either in Caleb or Nathan's class. So if Nate can wave, he might be waving to his sister there. All right, sorry. So what was your question again?
Hi, my name is Lydia. How do you get electricity power?
Great question. And Nate will just watch in here while we're answering. There is what's called a life support buoy, I think I mentioned earlier, that's basically moored above us. Wave bye to Nate. And it has a set of generators up there that are running off of diesel power, and they work in conjunction with each other to pump power down to us through an umbilical that also provides our communications with the surface, as well as gas supply for breathing air.
So that buoy is extremely important to the success of NEMO, and you're seeing some video of that. Usually, I think the operators there hope for a very calm sea, but I think earlier this morning we had an Aquanaut on that said you've been experiencing some rough seas lately. You've been able to move past that, which is good news to hear. But we're going to go to Dunbar Middle School because they have another question. Dunbar, go ahead.
What important discoveries have been made by NEMO missions?
I think I can tie that into our some of the work that we're doing here. The center of gravity work that I mentioned has been ongoing for a number of years, and over those years, we've been able to already help to guide some of the spacesuit concepts that are going to move forward in terms of where weight should be on the spacesuit if we're going to have weight for a portable life support system, for instance. And you might, as you kind of might imagine, some things we understood, and it kind of makes sense that the lower and something that simulates where your natural weight distribution is, so that it's more like you walking around in your classroom there, the better. But some other things, like if you're going to have weight on your back, if it's going to be behind you, you want to have it higher rather than lower, so that you can bend forward and kind of balance better if it's and things of that nature. So it's been really important work, and we're continuing to fine-tune that research so that we can make even better suits in the future.
All righty. Good information. I'm sure the students are learning so much by your experience these past several days. But we have 4 last questions, and I think we can get to them in the next 6 minutes. So Key Peninsula School, I think you have a really good question for Steve, because it's not like you can just show up one day and go to Aquarius and do a 2-week-long mission. So Key Peninsula, what was that question?
Hi, I'm Leland Kibler, and what did you have to do to train for this mission?
That's a good question, and part of it goes all the way back to our education and in terms of going to college and on to graduate school. My background, I had a aerospace engineering degree as a bachelor's degree, and then went on to get a master's and a PhD, and also in aerospace engineering, but concentrated in a field called bioastronautics, which is basically the study of humans and how our bodies react in working in space. And so having that baseline training and education was critical to my selection as a crew member. But once selected as a crew member, you have to have a lot of dive training. Some folks that get assigned to this already have dive experience. Some don't. So if you don't, you have to have scuba training, as well as training in the systems that we use when we go outside on those EVAs. I think you saw a picture of us outside with the backpack I mentioned, but we had a yellow helmet on, and that's a Navy system that's been in use for years, called a Superlight 17 dive helmet, that actually keeps your head dry, and it allows you to talk while you're underwater with your crewmates that are out there, and also within the habitat, and provides a video image of what you're looking at back to the folks that are inside. So training on all those systems, and then once we get inside the habitat too, the safety training for how to live and work in this habitat and do so safely and effectively was important as well.
All right, I see. So lots of training, but with that training, there also comes a lot of practicing. So as an Aquanaut, you have to get used to training and training some more. Now, Dunbar Middle School, this is going to be, well, maybe your second to last question. Go ahead and ask that second to last question real quick for Steve real quick.
Is the equipment used in NEMO the same equipment used in space?
That's a great question, and in terms of the life support type equipment, it is different. It's optimized to work here underwater, and it works well for the type of experiments we're doing, but it allows us to put on mock-ups of these primary life support systems, as well as build some of the early concepts that we have for how a lander might be organized and laid out, for instance, or the rover that you saw a picture of earlier. So while it's not the same equipment that will eventually go into space, it's an early prototype of how that equipment might be designed, so that we can get some answers as to whether it looks like it's going to be easy to operate, or if some changes might need to take place.
And who knows, Steve? It may be a prototype of the equipment that students like that are joining us today will actually really use on Mars one day. So. 2 last questions. Key Peninsula School has I thought, a very, very, very interesting question for you. So go ahead and open up your mic, Key Peninsula School.
Hi, I'm Melissa. Is it harder to cook underwater in Aquarius? And when you boil your water for your food, does it take longer than when you were at sea level?
That's a great question, and since as we're down here, we're at about 2.5 atmospheres, what they call it, of pressure, which means the pressure is 2.5 times what it is at sea level, or about 44 psi, a little more than what you have in your car tire. So because of that increased pressure, the boiling temperature of water is different. Kind of like the opposite of if you were to go to altitude. If you go to altitude, the boiling temperature of water is lower because of the lower pressure. Down here it's higher. It's around 260 degrees. So when water boils, it gets hot. It gets hot, much hotter. In terms of cooking, we haven't done much cooking. We have if you're familiar with backpacking, there's dehydrated meals that you boil the water and then you pour the water into the meal and let it sit for a while. And we have everything from granola for breakfast to rice and chicken for dinner. And it's all quite good. And then we supplement that with some things that we can keep in a small refrigerator, some fruit and vegetables and bread. It's been quite an experience. It's a great question.
I agree. One last question, Steve, and I think it has to do with some of the organisms that we see crawling across your window. So, Dunbar Middle School, you have the honor of the last question for Steve.
Has there been any interference issues or dangers with the wildlife in the ocean on Nemo's mission?
Let's see, not so far on our mission. There's certainly lots of sea life out there, and it's great to be out there in the environment with it. Lots of different types of fish. There are some that could be potentially dangerous, but we haven't had any issues. There's barracuda. There have been some sharks, shark or two spotted, stingrays. But it's kind of like being out in any environment in the wild, in a wilderness type of setting. As long as you leave most of those things alone and are respectful of them, they leave you alone. And it's great to be able to be out in the environment with them and work together as a team around them. And in a sense, come to their environment. It's where they're the boss and we're visitors. We're more like the alien life forms down here than they are.
That's a good way of pointing it, Steve. And I understand if you have to go, we are out of time, but if there's any last message that you want to give to the students, now would be the time.
Yeah, thanks for calling in and asking all the great questions. I hope that some of you get a chance to experience this type of mission in the future, and I'm sure that you will as NASA continues to push forward and with its mission of exploring the solar system, and continue to study hard in school and find something that you really enjoy and do well at it. That's the key to success, and along the way you'll have a lot of fun.
I couldn't agree more, Steve. I want to thank you personally for joining us. I'm sure the students had a blast interacting with you, and I can't say thank you enough. So goodbye from the Digital Learning Network, and good luck for the rest of your mission.
All right, goodbye. Thank you.
Thank you. Goodbye. All righty, students. In the next couple minutes, I thought it'd be fun to go around the room. Let's visit Dunbar Middle School. Can you guys go ahead and open up your mics and tell everyone what you thought about this program? Did you guys enjoy it?
Yeah. Hi, my name's Justin, and I just want to say it was awesome for you to be down there in the water.
That's right. And certainly if you want to learn more about Nemo, there's a number of ways to do that. You can visit our website at www.nasa.gov, and there you can find other resources, including Facebook and Flickr, among others. So there's a lot of computer and internet resources that you can use to learn more about the science principles of NEMO and some of the research that's happening. So thank you for your involvement, Dunbar. I hope you enjoyed it. But we're going to go to Key Peninsula School because I wanted to see what you guys thought about this program.
You know what? We'll do it. Oh. Yeah, Tyler. I like learning about the lunar and Mars training.
It was awesome.
Yeah.
Interesting.
Well, certainly that is good because when you guys are in your 30s and 40s, it's going to be people like that will actually maybe get to go and walk on the lunar surface and the Martian surface. So like Tom said, Steve, he said you need to study hard in school, especially in things like science and math if you want to get involved with NASA, because it does take a lot of science and a lot of math to explore outer space. So thank you one and all. You guys were a wonderful audience. And to say goodbye, we're going to visit with astronaut Joe Acaba. So before that happens, I want to say thank you again and goodbye from the Digital Learning Network.
Hi, I'm Joe Acaba. I'm a teacher and a NASA astronaut. Getting an education is the best thing you can do to prepare for a great future. But even after you graduate from school, the learning continues. For example, when I put on this spacesuit for a training session, I get to learn all kinds of cool and exciting things. We wear this suit when we train to launch and return to Earth on the space shuttle. It's called the Advanced Crew Escape Suit, but we usually call it the pumpkin suit because of its color. We carry all kinds of items in this suit, including lights, mirrors, a radio, and even a life raft. I get to learn about all of it, and so can you. NASA has a bunch of amazing products for students, including videos, neat education activities, and information about careers at NASA. It's all waiting for you at the NASA website. If you're interested, check it out. Who knows, you could be the one to design or wear the spacesuit that takes us back to the moon and on to Mars.